Hello and welcome to decimals. Today we are going to spend time talking about decimals. We're going to look at applications of decimals, relationships to fractions, how we can talk about decimals, how we name decimals, and the expanded form of decimals as well. So we're going to start off talking about general applications of decimals. So in regards to decimals, where have we seen them in the real world before? Well, I think a big topic right now, one way that you may remember decimals, is from temperature. Everybody's taking temperatures right now to make sure that we don't have fevers, right? And so we learned somewhere along the way that when you take a temperature, it can take on numbers like this, 98.7 or 100.2 degrees. And so here's one application in the real world of decimals, and that is temperature. Other ways or other places you may have seen decimals, well, of course, there's the other biggie, which are dollars and cents. $5.05. Here's something you want to see in your bank account, $3,465.19. Here's something you don't want to see in your bank account, negative $200.14. Right? So all of these are examples of decimals. We have temperature, we have money, we have measurement, 14.2 inches. We have weight, 128.7 pounds. There are so many different applications of decimals. So today what we're going to do is we're going to talk about, first of all, where does this word decimal come from? Okay, so if we take a look at the word decimal, you can see there's this D-E-C-I. And this D-E-C-I, or this D-E-C, is a prefix that often means 10. Think about it. A decade is 10 years, right? If you say decade is 10 years. So anytime you see the DEC, that means we're dealing with something that has tens in it. So regarding what that means for decimals are built on the base 10 system. Well, what does that mean? Well, let's do this first. Let's make sure that you're comfortable with the standard form of numbers that we talk about, the Hindu-Arabic number system that we know today. And then we're going to look at the relationships to fractions. And then you'll see what we mean or why we call them decimals, what that means when we talk about this idea of being a base 10 number system here for decimals. So in regards to the number system over here, okay, we know the smallest whole number place value are ones. So I'm just going to write that as 1 over here. The next place value system are tens. So let's write 10 over here. The next place value system are hundreds. So let's write 100 over here. And then the next place value system are thousands. So let's write thousands over here. You know, if we were to continue with that, the next one would be 10,000, then 100,000. And these number systems grow all the way to the left. We can have an infinite number of base 10 place values that will go all the way to the left there. Well, let's look at their relationship. How do you get from one place value to the next consecutive place value? Well, let's look. How do we get from ones to tens? How do we get from tens to hundreds? How do we get from hundreds to thousands? How do we get from thousands to 10,000s? Well, I hope you can see that there's a pattern here. To get from ones to tens, we multiply by 10. Well, does that rule work over here? Does that work from tens to hundreds? Let's take a look. From 10 to 100, multiply by 10. From 100 to 1,000, how do you get from 100 to 1,000? Same thing, we multiply by 10. How do we get from 1,000 to 10,000? Oops, look at that. We multiply by 10. So it looks like as you go to the left in our Hindu-Arabic number system here, the numbers start growing by powers of 10, right? We're multiplying them by 10. So what does that mean in regards to decimals? Because these are the whole numbers, and decimals are the numbers that happen in between the whole numbers. So what does that mean as we go to the right? Let's change numbers here. So let's say we're going now to the right. Well, how do we get from, let's go in the other direction. How do we get from 10,000 to 1,000? Well, instead of multiplying by 10, we would divide by 10. Well, does that work here too? From 1,000 to 100? Sure, well, 1,000 divided by 100 is 10. Let's go from 100 to 10. 100 divided by 10 is 10. Let's get from 10 to 1. 10 divided by 10 is 1. Well, let's continue going to the left now, and let's talk about how we can name all of these place values as we continue going to the left, and we're going to use that same pattern. So here we're at 1. Now we have to divide that by 10. Well, what is 1 divided by 10? 1 divided by 10 is 1/10. So this first place value to the right of the decimal, we refer to that as tenths. Well, what is 1/10 divided by 10? 1/10 divided by 10 is 1/100th. 1 over 100. Why? Well, let's just do a quick proof over on the side, and then you'll see why. 1/10 divided by 10. Well, you remember that when you divide, you flip the fraction on the right and multiply. That's the same thing as saying 1 over 10 times 1 over 10, which is 100th. Right? Multiply numerators, we get 1. Multiply denominators, we get 100. So this is 100th. Continue dividing it by 10 again. The next place value is 1,000th. Continue dividing it by 10 again. The next place value is 1/10,000th. Okay, so all of these place values that occur to the right of the decimal are based on a base 10 or a deci, right? There's a DECI, are based on a base 10 number system. So here are what the numbers look like regarding fractions. Let's talk about now how fractions and decimals are tied in to one another. We're going to do this first. I'm going to put some numbers up here. Let's write a number like this. Like, let's look at some of these numbers that we wrote up here. If we have a temperature that's 98.7 degrees, so 98.7 degrees. What does that mean if we have a temperature that is 98.7 degrees? Well, 98.7 degrees is the same thing as saying, well, I'm just going to give it a little bit of space over here so we can write it down over here. 98.7 degrees is the same thing as saying we have 9 tenths, we have 8 ones, and we have 7 tenths. So 98.7 degrees is the same thing as saying 9 tenths, which is the same thing as saying 90, 8 ones, which is the same thing as saying 8, and 7 tenths, which is the same thing as saying 7 over 10. So regarding what it looks like in fraction form, 90 plus 8 plus 7 tenths, that's the same thing as saying 98 and 7 tenths. So 98.7 in decimal form is the same thing as saying 98 and 7 tenths, 98 and 7 tenths in fraction form is the same thing as saying 98 and 7 tenths in decimal form, right? So that first place value, we're going to call that first place value to the right of the decimal, we're going to call that tenths because it's out of 10. Well, let's take a look at another example. What if we have this money in our bank account? So $3,465.19. Well, what does that number look like as a fraction? Well, let's think about this. I'm going to look at it first in expanded form, and then we'll put it in fractional form. We have 3 thousands. We have 4 hundredths. We have 6 tens, 60, 6 tens. We have 5 ones. And now regarding what's happening to the right after the decimal, we have 1/10 and we have 9 hundredths. So what does that mean if we have 9 hundredths? We can write that as following. So we have 1/10 and we have 9 hundredths. So we can write that like this. Now regarding what that would look like in decimal form, let's do fraction form first, and then we'll talk about what that would look like in decimal form. Just creating a little bit more space here, is we can rewrite that as 3,465, right? And now one way we can do it is 1/10 and 9/100ths. But another way that we can write that is if you take a look at this whole number over here, you can either call it 1/10 and 9/100ths, but another way that you can call it is 19/100ths. So we could also call it 3,465 and 19/100ths. So what that looks like as a fraction would be 3,465 and 19/100ths. As a decimal, that would be equivalent to saying 3,000, excuse me one second, let me just get that 19/100ths at the end of it. As a decimal, that would be the same thing as saying 3,465.19. So 19/100ths could either be called 1/10 and 9/100ths, but it's equivalent to saying 19/100ths. Okay, let's do a few more examples here, and then we're going to talk about how we would say these words. All right, another example. I'm big on examples. I want to make sure that you know how to convert these. Let's take a look at this example. So express the number, let's say 22.607 in fraction form. Okay, so what does 22.607 look like? First of all, I'm going to write it up here in my chart. I'm going to put my 22, 2 10s, 2 1s. Here comes my decimal point, 607. Okay, so in fraction form, what would that look like? Well, regarding the whole numbers, we know we have 22 of something. Regarding the fraction form, the way that we would say this number over here is 607, and the last digit lands on the thousandths. So we would say 607 thousandths. Now remember, there is another way to write this. So that is equivalent to saying 22 and, well, we have 6/10ths. We have no hundredths. And then, so we don't have to write it. I mean, if you want to, you can call it plus 0 out of 100, but you don't have to do that. And then we have 7 thousandths. So both of these guys are equal to each other. Here's one way of writing the number in fraction form. Here's another way of writing the number in fraction form. This number over here is the number that we tend to use. But again, remember that these guys are equivalent to each other. Now, I want to make sure that you're comfortable with how we would say that, because that becomes really important as well. How do we say these numbers when we're expressing them in decimal form, when we're expressing them in fraction form? Let's take a look at this example. Same directions, express in fraction form. How would you say it? Let's take a look at this example. If we had, how would we say that number? Let's express it in fraction form first. Okay, so let's go back up here to the chart. Okay, and we're going to call it 14.006. Okay, so regarding the whole number is 14. So we're just going to say in fraction form. That's the same thing as saying 14. Now notice here we have 0 tenths. So we don't have any tenths. We have 0 hundredths. We don't have any hundredths, but we have 6 thousandths. So the way that we would say this in fraction form is 14 and 6 thousandths. That's exactly the same way we would say this in decimal form. 14 And now here's a hint. When you hear the word and, that means a decimal's coming. So oftentimes, I'm going to write that over here to help you remember that. When you hear the word and, that means not oftentimes, that's what it does mean. When you hear the word and, that means a decimal's coming. So this is the same thing as saying 14 and no tenths, no hundredths, 6 thousandths. So this is equivalent to saying 14 and 6 thousandths. So now let's go in the other direction. So these examples say convert from fraction form to decimal form, and let's talk about how we would say these numbers. So example, express in decimal form. How would you say it? Okay. Let's take a look at something like 305 and 14 hundredths. Well, okay. If we wanted to express this in decimal form, 305 and 14 hundredths, that means I'm going to head back up here to the chart. 305 would go over here. And because the decimal is coming next, now 14 hundredths means we have to make sure that the 4 ends on the hundredths. And that would work if we put the decimal right here, right? We would say this number right here as 14 hundredths. So 305 and 14 hundredths in decimal form would look like this. 305 and, right, the end, the fraction and decimal are equivalent to each other. And 14 hundredths. So 305.14. Well, what if we had something that looked like 305 and 14 thousandths? What would that look like in decimal form? 305 and 14 thousandths. Let's go back up here. 305 again. Now we have to make sure that we have the number 14, and we have to make sure that the number 4 lands on the thousandths place value. So that means this time the 4 has to land on the thousandths, which is right here. So 14 would look like this. We know 4 goes here and the 1 would come before it. And regarding the tenths, we can't leave it blank. We have to show that we don't have any tenths. So we would put a 0 there to represent that. So this number is 305, and we would call this number 14. And remember, the 4 lands on the thousandths. So 305.014. 305 and 14 thousandths. Let's do one more. Okay, so let's talk about how we would express this in decimal form, and then let's talk about how we would say it. First of all, notice there's no whole numbers. So we don't have any whole numbers, so we're not going to worry about anything going on. Let's erase this guy at the top to give us more space to put it on the chart. We don't have to worry about anything going on in the whole number part. But if you look at it, you say, okay, there is a fraction. So that means, remember, fractions and decimals are equivalent forms. And the way we would say this number is 7 10,000ths. That means I have to make sure I represent the number 7, and the 7 lands in the 10,000ths place value. So 10,000ths is here. We don't have any thousandths, we don't have any hundredths, we don't have any tenths. So the way that we would, there's no whole numbers, so we don't have to worry about putting anything over there. So the way we would represent this number in decimal form is no tenths, no hundredths, no thousandths, but 7 10,000ths. So 0 tenths, hundredths, thousandths, 10,000ths. Now, for people involved in nursing math, a lot of times, if there is no whole number, we want to see that 0 there. And that just lets us know that there is no whole number, so you don't make mistakes when you're calculating dosages and things like that. So you really want to make sure that you put that leading 0 there before the decimal, and it's becoming more standard practice to do anyway. While they are equal to each other, just in medical circumstances, we tend to put those zeros there. So now that we're comfortable converting from fraction form to decimal form, assuming that we have base 10, right? Because it's decimal number system. Let's go back in the other direction. Let's convert from decimal form to fraction form. So we're going to do one or two more practice examples with that. And then we're going to end with expressing numbers in expanded form using both fractions and numbers. So how do we convert from decimal form to fraction form? Let's see if you can do this kind of quickly. We're just going to pull up two or three examples here. Converting from decimal form to fraction form. Let me write a real world example. Her temperature is 103.25 degrees. Okay, so what does that look like in fraction form? Well, we have a whole of 103. And remember, this 0.25, 2/10, 5/100. So one way we can call it is 2/10 and 5/100. But another way, and the more standard way of writing it, is 103 and we have 25 hundredths. So this is what this would look like in fraction form. One more. She needs 4.008 milliliters of Motrin. Well, what does 4.008 milliliters of Motrin look like in fraction form? That's the same thing as saying 4 wholes, right? And then 0/10, 0/100, 8 thousandths. So you could either call it 0/10, 0/100, and 8 thousandths, but that's the same thing as saying 4 and 8 thousandths. This is what it would look like in fraction form, again, using that base 10. So let's end with some examples and make sure that you're comfortable switching back and forth with expanded form using fractions and using decimals. So let's take a look at an example. Let's say, we'll go back to some medical examples here. Let's say her bone width is 6.052 centimeters. Okay, so what does that mean, 6.052 centimeters? Well, let's talk about this in expanded form for fractions. 6.052 centimeters is the same thing as saying 6 whole centimeters. 0/10, 5/100, and 2 thousandths. So this is what it would look like, centimeters. This is what it would look like in expanded form for fractions. Well, what does it look like in expanded form for decimals? Same. So now we're going to convert these guys into decimal form. So that bone width of 6.052 centimeters is the same thing as saying 6 full centimeters, 0/10, 5/100, right? 10ths, hundredths, and 2 thousandths. So in expanded form, this is the same thing as saying 6 plus 0.0 plus 0.05 plus 0.002 centimeters. Let's end with one more example. She needs a dosage of 14.106 milliliters of antibiotics. Okay, so what does that mean? Well, if we want to write this in expanded form, let's do fractions first. We have 1/10, right? That's a 10. We have 4 ones, 1/100, excuse me, 1/10, 0/100, and 6 thousandths. And then if we wanted to convert this standard form into decimals, let's say milliliters, same thing, and the whole numbers aren't going to change. It would be 10 plus 4. 1/10 is the same thing as saying 0.1, right? That's what that means over there. 0 hundredths is the same thing as saying 0.00. You don't have to write that in, but you get the general idea. So 0 tenths and 0 hundredths. And then 6 thousandths, which is the same thing as saying 0.006 milliliters. So here, I hope you are comfortable now with the relationship between fractions and decimals, why that we tend to call this system the decimal number system. These are all of the values that occur between two whole numbers on the number line. And the next time we meet, we are going to talk about what it means to order decimals and how we can determine which decimals are bigger than other decimals.